So we are looking for the critical value in this case for this upper tail test. And remember, what we are going to do is 40 degrees is the standard, but we are going to allow a certain margin above it. So the critical value will be above 40 and will be calculated this way. So there are two differences from the two-tailed test case. Two-tailed test critical values. First, there is only one critical value, which is on the upper tail, because we reject on the upper tail. And second, you have to use z of alpha, not alpha over 2. So remember these two differences, then the critical value is calculated this way. First, you should use plus here, and you should use z alpha here. So those two are the differences. And then algebra is simple. Pretty straightforward algebra. And then the result is 40.656. So you allow 0.656 degrees as a margin. So any coffee shop with like temperature above this level will be punished or rejected. Okay, now, so the reason why I calculated the critical value is to study type 1 error and type 2 error probabilities. You remember earlier in this chapter, we learned in the last lecture how to calculate the type 1 error probability and type 2 error probability at that time for two-tailed tests. Now we are going to consider one-tailed test, and the idea is the same. The calculation goes almost the same way, and actually even easier, because probability is only on one side. There is only one inequality inside the probability, so it should be easier to calculate them. So let's see. First, type 1 error probability. You don't need any algebra. Simply, I said type 1 error probability always equals to the significance level. Always. When I said always, it included one-tailed test, right? Any test. So I would say any test should have type 1 error probability equal to significance level. If they are different, then something is wrong. Something like maybe approximation error or theoretical errors. Anyhow, they are the same. But if you want to calculate them more from the fundamental, I can show you, right? The idea is that type 1 error happens when you reject the null hypothesis, but it was true. So when you reject true null hypothesis, then you have a type 1 error. So rejection happens when x bar is greater than the critical value, because it is an upper tail test. So greater than critical value, probability is this, simple. But remember, we assume that the null hypothesis is true. So the true mean is 40. The true mean is 40 in this case, which is used for the standardization, right? Standardization uses this true mean, therefore it goes like this. This probability goes like this. If you standardize by subtracting the mean and dividing by the standard error, you are going to get 1.64 again, which is z alpha. By construction, you should have z alpha here again, which will give you 5% again, which is the significance level. So simple, in summary, you don't need this algebra. Type 1 error probability is always the significance level. But type 2 error probability is not easy to calculate. Type 2 error happens when you do not reject a wrong null hypothesis, right? So we assume the null hypothesis is wrong. So we have to specify a value when it is wrong. And in this case, in upper tail test, you should choose a value that is upper tail. That is on the upper tail, because if you choose like say 39, then it doesn't make sense, because that is, in that case, H0 is not wrong. Like the served temperature is lower than 40 degrees, then that's okay. It's not rejected. It's not punished. So it's not a wrong hypothesis. So in an upper tail test, when you calculate type 2 error, you have to find a value above the hypothesis. If it was a lower tail test, then you have to assume a value lower than 40. So depending on which direction, the type 2 error happens only on one side, right? Upper side or lower side. Anyhow, so to make H0 wrong, you have to choose a value above 40. And the type 2 error probability is the probability of not rejecting the null hypothesis. So you do not reject if the sample average is not above the critical value. It's if and everything below the critical value is not rejected. So like inequality is simple, and standardization uses 41. 41 is the value you assumed. So use this, and standard deviation the same. So in the end, you will get minus 0.86, which gives you 19.489%. So approximately 20% is type 2 error probability. Now, once you calculate the type 2 error probability, the power follows automatically, because power is 100% minus type 2 error probability. So when the null hypothesis is wrong, if you reject it, that's power. If you do not reject, then that's type 2 error. So they are complement events. So power is 80% approximately, right? Okay, so we are heading into the last example, and it does not take much time than I expected. I'm going to stop here, and I will do the last example in the next video. See you later.